Yes, I have everything started. Everything is okay. I even have my picture right here. Water. Yes.
So it is from section 4.5, summary of the code.
Very good.
And it is y equals 2 square root x. And then outside of the square root minus x.
Excellent. And we want to graph, we want to do everything, right?
Yes, it's a summarized sketch.
Yeah. So we're going to summarize everything in the table. We're going to determine everything about the function first, and then about the derivative, and then the second derivative. Very good. I have to start with the domain. This is no problem, but this is the problem. Because I cannot take the square root from a negative number. So immediately I have to write that x is greater than or equal to 0, which makes the domain 0 to infinity. And then I start my table. So that's my first step. Let me know if I'm skewed, or if you can see, or if it's not clear, okay? Anytime. Okay. So I will have to find the x and y intercepts and the limit. So I will have to plug in 0. I will have to see if there is anything else in the term as x-intercept, and then the limit. That's all I need here, nothing else. This number, x-intercepts if there are more, and this limit. There is nothing else. So when x is 0, f of 0 is 0. But also, I have to write when y is 0, I have 2 the square root of x minus x equals 0. Because this may give me more. I know that this is already one x-intercept, but maybe there is another. I don't know. So what I'm going to do, I'm going to separate the radical from the rest, because this is a radical equation. And I will square both sides, and I will get 4x equals x squared. And I see clearly that this equation has x equals 4 as well. So x squared minus 4x equals 0, x minus 4. So obviously, I already discovered the x equals 0 from before, but it's also x equals 4. I don't know how close should I put it. I don't know what's going to happen here, so I'm going to leave some space. So there are two x-intercepts, the origin, which is also the y-intercept, and another x-intercept, which is 4, 0. Now, all I need is this. So I need to determine limit of 2 the square root of x minus x when x approaches infinity. And you can say, but this is a situation of infinity minus infinity, and what do I do? Because this approaches infinity, this approaches infinity, and it's infinity minus infinity. It's an indeterminate case. Rare situation, I can apply L'Hopital's rule, but if you look at it carefully, you will see that this is so much smaller than this. This term is the stronger one. This is too small. It will never go over this. So then when x approaches infinity, this piece approaches negative infinity, so the answer is negative infinity. And this is done about the function. Nothing else I can find. And of course it's not symmetric. I'm not going to waste my time with that. How do I know it's not symmetric? First of all, because of the domain. A function is symmetric if it has the same left and right of the y-axis, or across the origin, but there is no case, no situation here, so not symmetric. Okay, so now I can go ahead and find f prime. So this is 2, 1 over 2 the square root of x times the inner function prime, which is 1, and minus 1. I will simplify these. I will have 1 over the square root of x and minus 1. and the least common denominator is the square root of x, and this needs to be multiplied by the square root of x, so 1 minus the square root of x. I'm in search of critical numbers next. And I know that critical numbers come from two sources. One, when f prime is undefined, and the function is defined. And the second option for f prime of x equals 0. Looking at this, I will say it's undefined when x is 0. That's a critical number, because the function is defined at that point. So if the first derivative is undefined, the second derivative will be as well. So now, is there something coming from f prime being 0? Yes. This fraction is 0 only when the top is 0. 1 minus the square root of x is 0. Or 1 equals the square root of x. Of course, I square x equals 1. Here, I should have gone back to check because I squared both sides, but it works. So 2 times the square root of 4 is 2. 2 times 2 minus 4 is 0. So both work, but I should have said that because when we square both sides, we have to check solutions. Same thing here, when I check 1 minus 1, it is 0. So I have to put 1 in the table, and I get 0 for the first derivative. At this point, I have to study the sign of the derivative to make sure that these two are correct. They have to work in sync. If they don't work well together, I'll say oops and go back to the drawing board. Okay, so this is always positive. I'm not going to waste my time to plug in anything in there. But in the top, when I plug in 0, I get positive. When I plug in 4, I get negative. So I found the sign. When I plug in 4, it's negative. I have to determine this value here, but that's not difficult. It's 2 minus 1, which is 1. Now is the moment of truth for these two. So from 0 to 1, oh yeah, it is true. From 1 to 0, yes, it is true. From 0 to negative infinity, yes, it is true. So the first two rows work well. But now I'm here. And I'm going to rearrange all this. I'm going to use this, not this, to differentiate. So I will be using f prime as x to negative 1/2 minus 1. X to negative 1/2 minus 1. Because when I differentiate, I will bring negative 1/2 in front. I subtract 1 from the power. And when I differentiate negative 1, I get 0. So this is negative 1 over 2. And this is the square root of x to the third. Okay, so I realized that this is never 0. And furthermore, because x is always positive, so this will be always positive. The whole thing will be always positive, but since it has a negative in front, it will always be negative. Which means the function does not hold water, and it does not have inflection points. At this point, I'm ready to graph. I don't care for anything else but the table. I shouldn't even graph this. Makes no sense. Okay, so at 0 is 0. At 1 is 1, 2, 3, 4. So the function is increasing to this maximum, which is a local max. It will turn out to be an absolute max as well. It has the x-intercepts 0, 0, and 4, 0. It's increasing and then decreasing, and it's always opening down. No problem. So this is the graph of 2 to the square root of x minus x. you should always check just to make sure there's nothing that can go wrong here for this particular case. But I can plug it into the square root of x and then minus x. I don't care for the viewing window to the left hand side. I only care about 0 to 8 with a scale of 1 and -4 to +4 with a scale of 1. I just want to see that. Oh, I messed up something. Let's see what I messed up. Oh, I put the scale of -4. Nobody cares about that. So -4, oops, -4 to 4. Yes, good. So here's the graph. As expected, it starts here, it has a vertical asymptote. Maybe I should graph it better. It has a vertical tangent, I meant to say. A vertical tangent, that's why the derivative is undefined there. It reaches a maximum, which we know is at 1, 1. It crosses at 4, goes to -infinity. Exactly as we expected. Any questions on this, Sean? Is this okay? Anyone? Good. Anything else?
There was one thing, and it was so it was part of give me a second.
Yes. Newton's method. Very good.
Yeah.
Very good.
There's the second derivative for one of the problem. So I was able to figure it out by looking at how they did it, but I'm not sure how they got to it.
Yeah, so let's start the problem from the beginning because I don't know, everyone should be able to see it, so I don't want to start in the middle, but it's up to you, whatever you want me to do.
Well, we can start from the beginning.
Okay.
So it's 6e to the -x squared sine x equals x squared minus x plus 1.
Okay. Did we do this together? It just rings a bell, but maybe not. It doesn't matter. I'm not looking at anything. I'm just uploading the next video for the previous class so I can. Just 1 second. So first of all, we have to create the function. By creating the function, we mean we have to move everything to one side and set it equal to 0. You got the chance to do that, right? And 137, 550, it was 4.5, 5.1. Part 2, April 27. Okay. So I let this do its thing in the background of this computer. Okay, so our first step has to be moving everything to one side. So this is a 6e to -x squared sine x minus x squared plus x minus 1 equals 0. And this is our function. In step number 1, I have to write that f of x is continuous as a combo of continuous functions. Because I'm getting it ready for the intermediate value theorem. In step number 2, I have to find an interval. So I will have to put the function in the calculator. In y equals, clear, 6e in parentheses, -x squared, close the parenthesis, sine x, close the parenthesis, minus x squared, plus x and minus 1. So I put the function in, and I go to second and table, and I will try to plug in some numbers. So let's say -1, let's say 0, let's say 1. I found it, between 0 and 1. That's good enough. I see that at f, let me make sure the mode is in radian. Yes, it is. So I found that f of 0 is negative and f of 1 is positive. So then I would say from 1 and 2, by the intermediate value theorem, there must be a number c, at least between 0 and 1, such that f of c is 0. In other words, what this is saying is there is a solution between 0 and 1, go ahead and look for it. But that's where you should look for it. Between 0 and 1, there is a solution. There may be others, but at least between 0 and 1, for sure there is a solution.
So I forgot to tell you it's finding find all the roots of the equation.
Right. So if you remember last time I said I don't need you to find 10 roots. I just pick one.
Okay.
And you can repeat by simply graphing the function, right? So I'm fine if you just find one. Once you graph this function, let's say I'm going to graph it in standard. From the graph, I'm hoping to see maybe more than one solution. But you're not going to be asked during the test to find more than one. So I'm assuming maybe I can just go and widen the graph, but I'm assuming that it only has two solutions. One between 0 and 1 and one between 1 and 2. But once we illustrate with one of them, then you can determine the other in the same way. Is that okay?
Yes.
Okay. But on the test, I'm happy. Remember I said if you don't want to put anything in there, put 0, and I will look at your notes. That's all I care about. Okay, so now we create Newton, and let's say we start with x0 equals 0, but I have to be careful because I have to look at f prime. Now I have to be very careful because this is function 1 and this is function 2. I have to use the product rule. 6 can wait for a moment. E to negative x squared is e prime is this times the second function, sine x, and then plus e to negative x squared times sine x prime, which is cosine x, minus 2x and plus 1. I have to make sure, because remember Newton's method is x minus f of x, 6 e to negative x squared sine x minus x squared plus x minus 1 over the derivative, right? So if the derivative is 0, then the method will not take me anywhere. So when this is 0, this piece will be 0, this piece will be 0, this will be 1, but cosine is 1, and 1 plus 1 is 2, so I'm fine. I made an error. I just realized I put the parenthesis in a different spot. It should have been before negative 2x. So it's 6 first function prime times the second plus the first times the second prime, close the parenthesis, minus 2x plus 1. My apologies. You know, in 5 minutes from now I would have gone nuts, because I have to find an answer between 0 and 1. And who knows what I would have found. Sorry about that. So I will distribute. So I have negative 12x e to negative x squared sine x plus 6 e to negative x squared cosine x minus 2x plus 1. These are all in the denominator. So now we're ready to put this in the graphing calculator. Do not delete what you had before. You already had the numerator. So let's insert x and subtract and put parentheses. So I put in x minus and parentheses. Do not forget we need parentheses around the numerator and parentheses around the denominator. So I already have the numerator. I put the parentheses. I need to finish with the other parenthesis. Go all the way. close the parenthesis, and now divide, open another parenthesis, negative 12x e in parentheses, negative x squared, close the parenthesis, down from there, sine x, close the parenthesis, plus 6 e 2 in parentheses, negative x squared, close the parenthesis, down from there, cosine, ooh, cosine x, close the parenthesis. I distributed, just making sure now, yes, everything is okay. Minus 2x and plus 1 and close the parenthesis. After you enter all this, second and quit, get out of there, call the function, press variables, call the function, y variable, it's a function, yes, it's y1, yes, and plug in 0 in it. How many decimal digits we want, Sean?
It's asking for 8 decimal points.
My goodness.
But so for the denominator, I got a much different way of how they represented it. So I got
I didn't want to put too many parentheses, so that's why I wanted to have it. I could have factored out the 6 e to negative x squared. I don't want to do that.
okay.
Only because I don't want to have nested parentheses. If I miss one, then the whole thing blows up. But it's the same thing. It doesn't matter.
Thank you.
Thank you. So I plugged in 0, and I pressed enter. So my first solution, my first iteration, if you want, not solution, 1, 4, 2, 8, 5, 7, 1, 4, 2, 9. Now I go to second and entry, but I overwrite the 0 with the previous answer. Make sure you have it here, because if you perform some other calculations in between, it will not choose the previous answer. So x2 is 0.14930405547, and now I don't have to do anything. It will automatically take the previous answer. So x3, the third iteration, 14933011756, and x4 0.149330176. 2, 4, 6, 7, 8. Okay, we're done. There is no point for number 4 because 8 digits already repeated. 1, 2, 3, 4, 5, 6, 7, 8, and they are the same. So this 2, 4, 6, 8. This is the solution. One solution, as we looked at the graph, there is another one. Any questions?